Okay.
You're starting on 60.
Yes. Remember, I don't make the plans, I just follow them.
Okay, sorry.
But apparently, they kind of make sense, because I'm assuming you did 1 and 2 at some point, and or they get looped into something else. Yeah. All right, so 6.3 is called Piecewise Functions. And again, that's a typo on that very front screen, okay? So a piecewise function is, okay, so like let's say a function is f of x equals 2x plus 1. That's a function. A piecewise function has multiple parts to it. So it says for these values, the function is this. And for these values, the function is this. So it changes, okay? So it's like multiple functions in one, depending on the value of x. That's the idea behind a piecewise. So it's a combination of more than one functions. And you'll see in a minute, we're going to do 3 things with these. One is identify the values from a graph. The second is evaluate by plugging a number in. And the third is graphing the piecewise functions, which we'll do tomorrow. So in order to do these, you need something called interval notation. When you're using interval notation, a square bracket indicates an included endpoint or solid dot, and parentheses indicate an excluded endpoint or an open dot. So we're going to read, oh, sorry. All right, so interval notation can come from an inequality. So let's say I said that the values of x are greater than or equal to 3. This is saying start at 3, include 3, and then all the values after 3 or bigger than 3. So when you write interval notation, you're actually showing the range of numbers that is a solution to this. So you start with the smallest number. The smallest value for this would be 3, and you go to the largest value. So if it's greater than 3, is there an end to it? It could go to what? Infinity. So with interval notation, an or equals to, which is going to be an included point, gets a bracket. And then infinity gets a parentheses. So is infinity a number? Can you give me the value of infinity? No, which is why it gets the parentheses. Okay? So interval notation is on the right, inequality on the left. If I say x is greater than 3, now am I including 3? No. So an non-including 3 means start at the next number after 3, which is like 3.00000000001, but don't include 3, which is why it gets a parenthesis. And then go on to positive infinity. And then the opposite would be if it's less than. So let's say x is less than or equal to 3. What's the smallest value x can be? Negative infinity. And what's the biggest value x can be? 3. And does it get a bracket or a parentheses? Good. A bracket, because this time we're saying or equal to 3, so it's including 3. And then if it was just less than, negative infinity to 3, and this time parentheses. So if it has an or equal to, it gets the bracket. If it doesn't, it gets the parentheses. So you're going to be reading interval notation from a graph. But you got to obviously understand what it is first. So this says complete the table, give the domain of the function in interval notation, and give a verbal description to represent the graph. So this is what's called a piecewise function. Specifically, this is called a stepwise function. But what it's saying is that for different values of x, my function is different, right? Like these are 3 different lines. Everybody sees that, right? And they're true for different values of x. So from the value of x being between 0 and 2, my line is at 8. We see that? Yeah. From 2 until it looks about 5, my line is at 6. So the value would be at 6. And then from 5 off the graph, which means positive infinity, my line in this case is at 5. The y is at 5. You see that? So what we have to do is figure out what that means like in terms of this. So the x is the weight. So you went to like Fresh Market or Whole Foods. You picked out the trail mix or the candy or whatever it is. You put it in the bag. You go to weigh it. Okay? If your weight is between 0 and 2 pounds, then the price is $8 a pound. If it's from 2 to 5, it's $6 a pound. And from 5 to positive infinity, it's $5 a pound. Okay, so the price varies depending on how much is in the bag. Does that make sense? All right, so now we got to figure out how to write that in terms of numbers. So if this first range is from 0 to 2, then I would write 0 to 2 for my weight. Does it include 0?
Yeah.
Yes. Does it include 2?
No.
There's an open dot here. Does that make sense? So that's a parentheses. And so from this line, what's the price per pound? $8. So the first range, if I just move from left to right, it's probably the easiest way to read it. The first range is from 0 to 2. My red line is at 8. So from 0, which technically that's a solid dot. Even though it's on a dot, there is not an open dot there. So it's saying from that point up until this point, but not including that point. So not including 2, which is why it gets a parentheses, not a bracket. That my price is $8. So now what's the next range of X values? 2 to 5. So 2 to 5. And this time, what's on my 2? An open dot or a solid dot? Which means bracket. And on the 5? Open dot, so it's a parentheses. What's the price per pound? $6 per pound. And then the next range starts where? So this is the Y value. So this is my X, right? And this is the Y. It's okay. So then what's the next X start at? 5. And it goes till off the graph, which means positive infinity. Good. Almost. Brackets on 5, but parentheses on infinity. So infinity or negative infinity will never get a bracket. Always a parentheses because I can't include that number.
How did you know the first one was from 0 instead of 9?
Because if it didn't want you to include 0, it would have an open, it would be like that. So open dots should be obvious. But if I'm moving from left to right on this, right? It goes from 0 to 2. I'm sorry?
Then why isn't there a closed dot?
A point on the line is technically a closed dot.
Oh,
So all of these dots are technically closed dots. Does that make sense?
Yeah.
Wait, so is like the 0 a closed or open dot?
It's a closed dot.
Oh.
It will have an open dot if it intends for it to be open. If it's a line or a solid dot, it means solid dot.
So
this line is full of solid dots, even though it's not literal dots. These are all solid values, you get me? Until you get to there, that's an open dot. Open dot represents a parentheses.
So if that had an open dot, then that would be negative infinity too?
So if this had an open, well, you're not going to have anything with a negative weight, really,
Okay.
would be the idea behind it. That's what you mean? Why isn't it negative infinity?
Yeah.
Up until it, yeah, so you're not going to have something with a negative weight. Okay, so then the price at that last range is what? This last bar, what's my price? $5 per pound. Ian.
On the last slide, when you were doing the examples with the
Okay, so I'm going to give you a minute to try this, but notice that my graph, the Y is on the left and the X is on the right, okay? So look at the title and follow it that way. So the green fees, there's 3 different kinds, and then what time range does that match? All right, so start with so hopefully if you look at that graph, you should have seen that these don't go by ones, right? What is each gray line? 3. So this would be 3, 6, 9, 12, 15, 21, 27, and 30. So what are the 3 different prices that are being charged for these green fees?
20, 24, 12.
28, 24, and 12. Good. So $28 is charged from what time to what time?
8 to 12.
From 8 a.m. to noon. Okay. And what gets a bracket? What gets a parentheses?
8 gets a bracket.
Good. Good. So if you are there at 11:59 and 58 seconds, you're getting charged $28. But as soon as that clock changes to noon, what happens? I get charged $24. Yep. Well, usually if it's implying something after, like the fact that this is set up at a time, and again, you can kind of like apply some real world thought to it. It's kind of saying that there's nothing that happens before 8 a.m. If there was time before 8 a.m., it should be on that x-axis, because otherwise you're shifting to negative time. Does that make sense?
Then how come like with like the other one we've seen that like it went infinity the other way?
Because you're moving beyond it to the right instead of to the left. So negative values are going to happen to the left.
So you don't have any negative.
You're going to have a negative time. Does that make sense? Just like a negative weight, you're not going to have a negative weight. You can go over whatever that pound was. You can go over 8 pounds or whatever it is, but you can't go under 0 pounds on something. So then from noon until what time is that 24? 4 p.m. And the 4 p.m. gets the parentheses. So again, 3:59 and 59 seconds, and you're getting $24. But as soon as that clock rolls over to 4 p.m., I'm now getting charged $12. So from 4 p.m. to infinity, anytime after 4 p.m. So obviously with time, your time's going to stop. It's not going to go positive infinity, but you can kind of get the application. So then it says, give a verbal description to represent the graph. So this is a really good like SAT type of question. What does this tell you? What kind of information can you give me from this graph? And there's like a lot of answers you could give to this. So pretend you're actually making a plan to go to this golf course. What does this information help you with?
It helps you with the fee-time relationship.
Okay, so you would know exactly how much you're paying depending on what time you're arriving. Okay, what if you were trying to figure out what's the most cost-effective time to go? What does this information tell you?
That at 4 p.m.
Good. The later you go in the day, the cheaper it is. Does that make sense? So these are all like some real-world application based on this information. Okay, how does this information help you? All right, this is called a stepwise function. So stepwise function, so piecewise just means it's got different parts. Everything we've looked at up till now is a stepwise function, which means that it's constant for the interval, which means that these are horizontal lines in these intervals. And it says you can describe piecewise functions with a function rule, meaning for these values of x, my f of x equals blank. For these values of x, my f of x equals blank. And for these values of x, my f of x equals blank. So if I were to actually take this information and put it into a graph form, so let's say I'm going from 0 to 13 to 55, and they are not equally spaced, but you can kind of get an idea. And then let's say my y values, which are these, are going to be at 5. Let's say this is 9. Let's say this is 6.5. So from 0 to 13, I should have a horizontal line at 5, which means from here with an open dot this time because it's greater than and not greater than or equal to 13, that's my first step. So step would mean that horizontal line. From 13 to 55, and this time we include 13, it's a solid dot. The value is 9. And then from 55 and beyond, the value is 6.5. So this is how you would graph a stepwise function. We're going to get into piecewise in a little bit. Actually, I'm going to save the graphing part of it for tomorrow, but just so you can get an idea.
Wait, so the ones we were doing?
Those were already, they're called stepwise functions, but they are a specific kind of piecewise. They're still piecewise, but what makes them step is that each part has a horizontal line. Because you can also have, and you'll see it, you can also have a graph that's piecewise that looks like this. So I can have a line mixed with a constant mixed with a parabola, okay? What's happening here is I have 3 different functions for different values. That's what makes it piecewise.
I see.
Ian?
So the blue one up there, the 9 one?
Yep.
That's basically saying that like any value you put into that function that's that's greater than or equal to 13, or and less than 55, it'll give you 9.
Correct. So if I asked you, what's the value of f of 20, you would tell me it's 9.
Because
Anything in between 13 and 55 is going to be 9. Anything from 0 to 13 would be 5, and 50 and 55 and beyond would be 6.5. Okay, which is our segue because that's what's coming up. So evaluating the piecewise functions is what you're going to do next. So this is actually give me the answer to a function if I give you the value. All right, so to evaluate any piecewise function for a specific input, find the interval of the domain that contains the input, and then use that rule for that interval. So this is what a piecewise function can look like in algebraic form. It says that h of x is either 2x plus 1 or it's x squared minus 4, depending on the value of x. So it's saying if x is less than or equal to 2, then use the top rule, or the top function. If x is greater than 2, use the second function. So if it says evaluate for x being -1, am I using the top one or the bottom one? Is -1 less than or equal to 2, or is it greater than 2? Yep, good. It means I use the top one. So then I would just take this, plug it in. -2 plus 1, which is -1. And then it says evaluate it for x equals 4. So do I use the top one or the bottom one? The bottom one. So 4 squared minus 4, 16 minus 4, which is 12. I mean, this is what happens here, right? This time it says evaluate the piecewise function. This time there's no plugging in involved. It's already telling you what the answer is. You just have to figure out which range it is. So x equals -1 would be in the top range less than 0, less than -3, in between -3 and 6, or greater than 6. Which one? It's going to be in that second one. It's in between -3 and 6, which means my answer is 15. So this time I don't even have to plug anything in. How about x is 3? Is that on the top, the middle, or the bottom? It's also in the middle, which means this is also 15. So again, if you think about the way this would look on a graph, this is saying from anything left of -3, and then -3 to 6, and then bigger than 6. These values would be at, let's say this is 12, 15, 20. These values would look like this. This value would be like this. And then this would be like this. So if my x is -1 or +3, it should make sense that the y value would be that 15. What if I asked you to evaluate where x is 6? Well, it would be the last one. Good. It would be 20. Why is it not 15?
Because 6 is not included in 15.
Good. 6 is not included in 15. It has to be less than 6. Does that make sense?
Mm-hmm.
So if I said 5.9999999, my answer would be 15. As soon as I switch it over to 6, it now becomes 20. Questions so far?